angles, which means angle ABC is congruent to angle DBE. Yes, I'm recording the lesson because the student left. Okay? So complementary angles are two angles whose sum is 90 degrees. Okay? So two angles that, when you add the measure of one to the other, you get 90 degrees. So for example, look at angle A, 65 degrees. Angle B, 25 degrees. You add them, 90. So you say angle A and B are complementary angles. And if you were walking down the street and somebody stopped you and they showed you two angles and they're like, hey, look, these two angles are complementary. You're like, oh, which means their sum adds up to 90. So I say, oh, that means measure of angle A plus measure of angle B is 90. And the converse, we call it the converse, in the opposite direction. If somebody says the measure of A plus the measure of B is 90, then immediately you know that they're what? Complementary. Right? And look, it's spelled with an E. So not like you're paying somebody a compliment, right? They're not complimenting one another. They're complementing one another, okay? Like they add up to 90, okay? Okay, so how do we use this? Well, we have to look at angle relationships, determine how they're related, and see what operation we can do to solve for x. Okay, so give me 1 second and I'll get your question, Harrison.
I was just going to say something about it.
You were going to solve it?
Yeah.
Go.
Wouldn't it be 2x plus 10 plus 5x minus 5 equals 90?
Well,
Or equals 90?
what do you guys think? No? Julian?
Are they equal? So it's 5x.
Why are they equal?
Because they're both 90.
Not complementary.
They're
They're vertical angles. You see how they're lying, like, you see how like one angle and the other angle, it's like they're stacked vertically, right? So, they're vertical angles. Like, obviously, like this and this are also vertical angles. Like if you turn it around, you can see that they're stacked vertically. But those are vertical angles, which means they're congruent to each other. So you say 2x plus 10 equals to 5x minus 5. Subtract 2x. So 10 equals 3x minus 5. Add 5. 15 is 3x, so x is 5.
But for B, would you add them?
Okay. So when I was taking geometry the first time, I only took it once. When I was in geometry myself, it's like I took geometry 10 times, but the first time. Okay, so often diagrams get a little confusing, and I always used to kind of get turned around. I was like, are those vertical angles? Are those vertical angles? So suppose you want to determine whether angle 1 and angle 2 are vertical angles. Here's how you do it. Take one side of angle 1 and continue through. Okay? Take the other side of angle 1 and continue through. Do you see how the two lines I drew highlighted angle 1 and angle 2 perfectly? That means they're vertical angles. Okay? We'll do it again when we come into another example. What type of angle is this and this now? Complementary, because together they make 90. So we say 3x minus 2 plus x plus 4 is 90. Okay? So here, 4x plus 2 is 90. 4x is 88. X is 22. Okay? All right. Okay, look at this one. Find the measures of two complementary angles if the difference in the measures of the two angles is 90. Okay, so this is kind of tricky. So first we need the two angles, right? Okay, so here's how we do it. I have like one angle and I have another angle, right? Okay, I don't know how much each of the measures are. I'm going to call the measure of one angle x. So I'm going to say, let x equal one angle, the first angle. Okay. The two angles together, they have measures that add up to 90. So if this has a measure of x, what's the measure of the second one? How much? Well, if they're complementary angles, then it's 90 minus x. Does everybody get that?
Yes.
Okay. So suppose two angles are complementary. Suppose this is 40 degrees. How big is the other? Can you please put your mask up? Make sure it's like really tight around your nose. If this is 40, how big is the other one?
50.
How do you know that?
Because
90 minus
50.
Right, you did 90 minus 40, so you got 50. Okay, so now, if this is x, then how much is the other one? 90 minus x. So if x is the angle, 90 minus x is the complement. Now, look at what this is saying. The measure of two complementary angles, right? If the difference in their measures is 90. I'm sorry, it's 12. So 1 minus the other is 12. So, yep, so x minus 90 minus x is 12. Okay? So now you do the problem. You distribute the negative. X minus 90 plus x is 12. 2x minus 90 is 12. Add 90 to both sides. 2x is 102. So x is 51. Okay, now, if two angles can add up to 90 and be complementary, well, then they can add up to 180 and they're supplementary. So, supplementary angles are two angles that add up to 180. Look at angle 3 and angle 4. Do they add up to 180? Yeah, they form a straight angle. They're also a what? We learned before. This one. This one. A linear pair. Okay. So if angle 3 and angle 4 are supplementary angles, it means measure of angle 3 plus measure of angle 4 is 180. And what does the opposite mean? Yes. Angle 3 and angle 4 are supplementary. Okay. Okay, so this is a similar one to what we did. The measure of the supplement of an angle is 60 less than 3 times the measure of the complement of the angle. Oh my God, words, too many words, right? How many? Okay, I would get lost like right here. Right after this, everything would just go down the drain. So now I go back. And I go, okay, I got to do this one step at a time. The measure of the supplement of an angle. If the angle is x, how much is the supplement? 180 minus x. Yeah. In math, what does the word is do? Equals. 60 less than 3 times, okay, I'll come back to that.
So 180 minus 3x minus.
The measure of the complement of the angle. If the angle is x, how big is the complement? That's the supplement.
Measure, oh no, it's.
And the complement?
90.
90 minus x.
So would it be 1.5 minus?
Okay.
So we're getting 1.5.
So let's see. So look. So here's what we do. Look. We're not there yet. Hang on. We're not there yet. Let x equal the angle. Okay. Let's do it this way. Then 90 minus x is always the complement. 180 minus x is always the supplement. Okay? So now let's read the sentence again. The measure of the supplement is equals. Okay. 60 less than, so that's blah, 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 minus 60. 3 times the measure of the complement. 3 times the complement minus 60. Now, look at the equation and tell me if I wrote that correctly. Let me read the sentence to you. The measure of the supplement is 60 less than 3 times the complement. Yeah?
Yes.
Okay, you see how you can go back and forth and check? Now comes the algebra part. Okay? So, distribute the 3. This is why we make you guys take algebra before geometry. 270 minus 3x minus 60. The one advice I give you is don't try to do it all mentally. Write them down. I don't give extra credit to people that do it mentally, right? Equals 270 minus 60 is 190, 210 minus 3x. So add 3x to both sides. You get 2x. Subtract 180.
Did you get 4x? Oh wait, never mind. Sorry, that's a negative.
Yeah. You get
180 plus 2x.
30. So I did it in one step, yeah.
You did the minus.
Mm-hmm. So x is 15.
Now, should we always do it in one step? Or?
It's up to you. Like I said, I don't give points for doing things in your head. I like to do multiple things because I know different people do things differently, so I want to be able to like reach different people, right? I want to be able to, match different people's work. Yeah.
So you don't give extra credit for doing it in your head. So
Just the opposite, yeah.
do you take off points for it?
If on a test or a quiz, you just have an answer and no work, I may take points off because I would need to know where your answer came from.
Okay, so it's not
Like
just
on
a quiz.
On the homework too, you need to show work.
Okay.
Must show work.
Can we skip steps?
And it's not because I think you're cheating. It's because,
You want us to get in the habit of
yes, because if we're headed towards upper level math, then we need to get in the habit, okay?
Can we like combine steps?
Yeah, of course,
Like,
yes,
do
of
we have
course.
to do like the minus 180
No, you don't have to do that. If you can do it in your head, that's fine. But like, don't jump from step 1 to step 7 and then get things wrong. You know what I mean? So the next theorem, you guys already figured it out. When I asked you, what does this create? We kind of figured out that it creates a linear pair, doesn't it? Right? So that's actually a theorem. It's the supplement theorem. Okay? The angles that form a linear pair are supplementary. So look at angle 1 and angle 2. Do you see how they form a linear pair? Because the side of angle 2 that isn't in common with angle 1 and this side that's not in common, they form a straight line. So if angle 1 and angle 2 are a linear pair, that means angle 1 and angle 2 are supplementary. Okay? So we did linear pair, we did vertical angles. Next comes perpendicular lines. Okay? It's every math teacher's favorite type of lines because we like straight angles, right? When we put up a poster, we need it to be straight, right? Yeah, okay. So definition of perpendicular lines. These are lines, segments, or rays that intersect to form right angles. Okay, or a 90-degree angle. The symbol for perpendicular is this. So it's like a upside down capital T. Okay, so look, the diagram tells you that this is a 90-degree angle. Well, if this is a straight line, and if that's 90, then should this also be 90 to make it 180 together?
Yes.
Right? Yeah. And so now, if you look at this straight line, and if the first one is 90, then so should the other one.
Yeah.
And then so should the other one. So it's 90 all around. Okay? 360. Yes. Okay. So, this statement is saying line AD is perpendicular to line BC. This means, okay, that 4 right angles are formed. Okay? Okay. So, find x and y so that ray BE and ray AD are perpendicular. If I were to read this, first I would locate ray BE. That's ray BE and ray AD. And if I want them to be perpendicular, I put a little mark here. Okay? Now, if that's perpendicular, what do I know about this? Also 90, right? So then what do I know about these two? They are going to add up to 90. Yes, Clara, yes? So you want the lines to be perpendicular? That means this would be a 90-degree angle. And then how about 12y minus 10? Would it be 90? This one, 12y minus 10?
Oh yeah, it would be 90.
Yeah.
That would also be 90. Okay? Would you guys be able to solve that on your own?
No.
Yeah. Okay, I don't want to insult your intelligence here. I miss D period. Huh?
I'm about to give you a more difficult one.
Okay.
Then I'll sell your intelligence there.
So, okay. All right. So, so this is very, very important. How to interpret diagrams. When you look at a diagram, there are things that you can assume. There are things that you cannot assume. So, for example, look at this one. So, you can assume that all these points are collinear. You can assume that all of these intersect at H. Yeah, that you can assume. Look at some of the things you can't assume. You cannot assume that HM is perpendicular to HL. Like, you look at it and you're like, oh my God, that really looks like a 90-degree angle. Are you told that? No. So you can't assume, okay? Let's do some examples, because if I just read this to you, you can do that yourself. Let's do some examples. Determine what can and cannot be assumed. So, note we have some congruent marks. That segment is congruent to that segment. Angles are congruent. We have a 90-degree mark there. Can we assume that KHJ, this one, and GHM are complementary, the two starred ones? Can we assume that?
No.
Complementary, meaning they add up to 90?
No.
No. No. What do we know about them?
H, L, K, and
That they are congruent, okay? But they are congruent.
But I have a question for the explaining it. How do we explain it? Like how we know that it can't add up.
by
Well-
doing the equation.
Well, here, so no, you can't. All you know is that they're congruent, right? That's it. That's the explanation. Okay. So next, there's more explanation if it's a yes than a no. GHK. Okay, look, I always like to highlight these things, right? So GHK and JHK are a linear pair. JHK are a linear pair. Are they? Yes. Look at the two I highlighted, because this is the side that they share, but the sides that they don't share form a straight line. Yeah? Okay. So yes, because HG, ray HG, and ray HJ. So I want to be consistent with the book, not say they form a straight line, but we're going to say they're opposite rays. Are opposite rays. Thanks for agreeing with me there, Jacob. Okay? So do you see what I did? Even at this age, having done geometry for a very long time, I highlighted the angles, right? And I'm like, okay, common side, fine. The non-common side, okay, they form a linear pair or opposite rays. Next, HL. Okay, so then I erase. Okay, I like to do it with a pencil so I can erase the diagrams. HL, I'm going to highlight that again, is perpendicular to HM. Yes or no?
Yeah.
Yes. Why?
Because it's a right angle.
Because they show the right angle. There's a box. Okay? Yes. Because there is a square. Okay? Okay. So,